funny. Okay, apparently this is a legendary talk. The future of software again from Carpathy. I think he gave the talk of the future of software. So this must be a new iteration on it. And everyone is quite convinced that there is a ghost right here in the frame. Okay, there is a ghost behind this girl, and she's just looking off into the distance, and she's about to get her life taken from her. And nobody's concerned. Can we please get her on the phone and make sure she's okay? She's haunted.
Please welcome former director of AI, Tesla, Andrej Karpathy.
Wow, a lot of people here. Hello. Okay, yeah, so I'm excited to be here today to talk to you about software in the...
Sorry, I loved that intro. Just, wow, a lot of people here. And then the good 10 seconds of just not a lot of talking. That was great. Dude, I got to try that out for an intro.
Era of AI. And I'm told that many of you are students, like bachelor's, master's, PhD, and so on, and you're about to enter the industry. And I think it's actually an extremely unique and very interesting time to enter the industry right now.
I don't know if everybody feels like this is a very interesting time period to enter into the market. Does everyone feel like it's interesting and unique, or are we feeling like it's not that much fun? I think a lot of people aren't super stoked, but he's also talking to to be completely fair, Karpathy is talking to a whole group of people that are getting masters and doctorates in AI. So it's probably pretty interesting for them, okay? Because they're building, they're building out the future and everything. Dude, they just heard that Meta was doing $1 million signing bonuses, so they're like, "Let's go, boys! We're going deep on this one." Right, so maybe it's a little bit different perspective. You know what I mean? Yes, TJ, you are correct. This is going to be literally the Lord of the Rings Blu-ray edition extended scene of this talk. We're going deep on this one.
I think fundamentally the reason for that is that software is changing again. And
Okay.
I say again because I actually gave this talk already. But the problem is that software keeps changing. So I actually have a lot of material to create new talks.
Okay.
And I think it's changing quite fundamentally. I think, roughly speaking, software has not changed much on such a fundamental level for 70 years. And then
Software hasn't changed much in 70 years? I mean, 70 years ago, we were on punch cards or punch paper with mercury tubes delivering memory. And when we did the calculations for World War II for Fat Boy, those calculations were done around the clock with teams of 3 or 4 in a room that was 110 degrees freedom units. There was no such thing as a keyboard. We didn't have a keyboard, right? So it's has software changed? There's at least been one change. Can we all agree? There was, wow, that is horrible, to, hey, we have programming languages that run on all systems. There was, I would venture to say there was a couple changes. There was not even programming languages. Then there was programming languages, but the compiler and the operating system was unique, meaning that you wrote one thing for one computer and that's it. You didn't run anywhere else. And then our era, which started with Ken Thompson, right, who did Unix and C, and that's kind of our era. So I would at least say it's changed a couple times, going from no programming languages to write once, run only in one close, to this. Did he say 17? Oh, he said 17, not 70. Okay, well, that makes a huge difference. Okay, if he said 17 years, I totally agree with him, yeah. Dude, he's so right. Dude, bro's so right. It's crazy. Dude,
it's changed, I think, about twice quite rapidly in the last few years. And so there's just a huge amount of work to do, a huge amount of software to write and rewrite. So let's take a look at maybe...
Hold on. Hold on, redo this for a quick second.
It's changed, I think, about twice quite rapidly in the last few years. And so there's just a huge amount of work to do, a huge amount of software to write and rewrite. So let's take a look.
I don't understand why would we rewrite software if things have changed. First off, I need to understand what his change is. But what has changed so fundamentally that we need to rewrite software? Like, Rust? Is this... Dude, is he about to rust us? Are we about to get hit with a Rust bomb? Damn, that's crazy. I didn't... Okay, dude, the Carpathy Rust rewrite arc, I did not see coming, okay? That's crazy.
Look at maybe the realm of software. So if we kind of think of this as like the map of software, this is a really cool tool called Map of GitHub.
Oh, this is so good. This is so good. I like this. I like this a lot. Because you know what? I think it was Theo that I was arguing with. He was saying that like 50%, no, he was saying more than 50% of all repos are web-based. Or are like JavaScript, or I think he said it was like JavaScript and HTML. And look at this. There's like cloud, there's Swift, there's learning and Python, there's data. Here's some front-end stuff. There's C++ frameworks. There's the Godot land. There's intrusion arsenal. Not even sure what the hell that means. MERN. That sounds like, okay, that falls under that one. Bypass Bastion. Not even sure what the hell that is. Flataria. Is that Godot Island? Yeah, that's the island of Dr. Monroe, actually, where they have the little freak babies and they do all that stuff. It's weird. It's weird. You wouldn't want, you don't want to go there.
This is kind of like all the software that's written. These are
Promptoria?
instructions to the computer for carrying out tasks in the digital space. So if you zoom in here, these are all different kinds of repositories, and this is all the code that has been written. And a few years ago, I kind of observed that software was kind of changing, and there was kind of like a new type of software around. And I called this Software 2.0 at the time. And the idea here was that software...
Oh, he did this in 2017. Interesting. Neural nets?
1.0 is the code you write for the computer. Software 2.0 are basically neural networks. And
Is that software or is that just an algorithm? Do you really call algorithms like software? I don't know about that. I mean, I've hand-rolled a lot. I know this is going to be a little bit shocking to some of you guys. But when I decided that I was going to learn JavaScript, I wrote a library 12 years ago, and this does neural nets, RBFs, and fizz, and colony optimizations, and evolutionary algorithms. Look at that. That's my email. That's my old email. And so, yeah, you know, like, I've been writing software 2.0 for a while. This was back when I was getting my master's in the old AI. The old AI.
in particular, the weights of a neural network. And you're not writing this code directly. You are more kind of like tuning the data sets, and then you're running an optimizer to create the parameters of this neural net. And I think like at the time, neural nets were kind of seen as like just a different kind of classifier, like a decision tree or something like that. And so I think it was kind of like, I think this framing was a lot more appropriate. And now actually what we have is kind of like an equivalent of GitHub in the realm of Software 2.0. And I think the Hugging Face is basically equivalent of GitHub in Software 2.0. And there's also Model Atlas, and you can visualize all the code written there.
I understand this. I don't know what's going on in this graph. Right? Like, what is this? What is this graph? I don't even know how to make sense of this. At least here, I'm like, okay, Promptoria. Yeah, I got this. Droid Smith Realm. Okay, yeah, I get this. I don't know what Jaxian, but I'm sure it's fantastic. Laravel. Okay, Laravelium. Okay, I understand this. This just looks like a fever dream. I'm literally looking at a fever dream right there.
In case you're curious, by the way, the giants...
Is this the same graph, except for this is what it looks like when you're on acid? Where's Mordoria? Yeah, that's right. We have Promptoria, but where's Mordoria?
Circle, the point in the middle, these are the parameters of Flux, the image generator. And so anytime someone tunes a LoRa on top of a Flux model, you basically create a git commit in this space, and you create a different kind of image generator. So basically what we have is Software 1.0 is the computer code that programs a computer. Software 2.0 are the weights which program neural networks.
By the way, this photo is definitely from the 70s or the 80s. There was no such thing as a QWERTY keyboard until, what, 80s or 70s? 70s? My guess is 70s. 70s must have came out. Probably 72. QWERTY, maybe 68. Anyways, okay. Neural nets. I have a hard time classifying software 2.0 as neural nets. But okay, but you know what? I'm gonna accept it. I'm just gonna say, okay, software 2.0 are these neural net learning functions for being like better classifiers. Okay, we're just gonna accept it.
Works. And here's an example of AlexNet image recognizer neural network. Now, so far, all of the neural networks that we've been familiar with until recently were kind of like fixed function computers.
Yeah.
Image to categories or something
They're
like that.
really stuck to
I think
something
what's
small.
changed, and I think is a quite fundamental change, is that neural networks became programmable with large language models.
Has anyone done any of like the smaller like MLPs? Anyone in chat back a decade ago? And do we got any MLP boys? Any of you guys? Okay, I assume we got a couple. Okay, we got a couple. I see a couple yeses in there. Yeah. The hard part about the MLPs and all this is that you really have like such a fixed function you're working on. You really like, dude, the amount of things you can solve with it, you have to have such intense data and all that, and it's just so narrow. So yeah, I mean, LLMs are quite magical. Okay, so software 3.0 is prompts. Huh.
And so I see this as quite new, unique. It's a new kind of a computer. And so in my mind, it's worth giving it a new designation of software 3.0. And basically, your prompts are now programs that program the LLM.
I would argue that software 3.0 is actually closer to software 1.0. It's just that the LLMs are a compiler. Right? I mean, isn't that all it is that the LLM is really just a compiler at this point? It's just a stochastic compiler that doesn't quite generate the same thing every single time, depending on the day, the month, the words you use and all that. Isn't software 2.0 like relying on kind of these tuned statistical models to just do one activity really, really well? And this one is actually more closer to this one where you're just like, I'm going to program a computer. I'm just going to compile English into code, and then hopefully the code then runs.
And remarkably, these prompts are written in English. So it's kind of a very interesting programming language. So maybe to summarize the difference, if you're doing sentiment classification, for example, you can imagine writing some amount of Python to basically do sentiment classification, or you can train a neural net, or you can prompt a large language model. So here, this is a few-shot prompt, and you can imagine changing it and programming the computer in a slightly different way. So basically, we have software 1.0, software 2.0, and I think we're seeing, maybe you've seen a lot of GitHub code is not just like code anymore.
Okay, I see what he's saying. So if you look at this thing right here, if you look at Python software 1, you literally have like a hard-coded set of words, right? You have two set of hard-coded set words, and you're saying, hey, if we're in the positive, then you get more score. If you're in the negative, you get less score, and we ignore all other words, right? And so then we can say, hey, this thing was positive. But okay, so you see the idea. Then this one is that you go and you give a whole bunch of positive examples, whole bunch of negative examples. You create the MLP that effectively has all the tuned, all the tuned weights to be able to do this kind of binary classifier. Maybe you have two MLPs, one for doing positive, one for doing negative. Bada bing, bada boom, right? It just kind of works. You do that, little training business. And then this one is that it like, you don't need all the examples. You don't need all this. It's all kind of already built into this one. Okay, I don't really get the difference between the two. Well, what he's saying is that in software 2.0, you train one of these neural nets for like a specific use case. Does that make sense? So it's like, I am training software, or I'm training this neural net to solve this one singular problem. Whereas, with the LLMs, I mean, they're just massive MLPs in many, many ways, that it's just like, instead it has every problem effectively solved underneath it.
A different way. So basically, we have software 1.0,
so they just trained more, got it,
software 2.0, and I think we're seeing, maybe you've seen a lot of GitHub code is not just like code anymore. There's a bunch of like English interspersed with code. And so I think kind of there's a growing category of new kind of code. So not only is it a new programming paradigm, it's also remarkable to me that it's in our native language of English. And so when this blew my mind a few, I guess, years ago now, I tweeted this, and
I still hate this. I hate this. The reason why I hate this is that English is ambiguous. You know, I've been trained in programming languages in which cannot be ambiguous, right? You cannot, there's like, that's the entire point of a parse tree and all this stuff, is that you cannot have two different states that can be created by the same syntax. And so having English, where English has all these nuances to it, you have this like entire weirdness that just crops up. Esperanto? Yes, we should be using Esperanto. You know, bros will do anything except for learn how to program. The AI bros will literally learn Esperanto to have a concrete language just so they can avoid learning a concrete language to program a computer. You know what I mean? It just seems like kind of crazy.
I think it captured the attention of a lot of people, and this is my currently pinned tweet, is that remarkably, we're now programming computers in English. Now, when I was at Tesla, we were working on the autopilot, and we were trying to get the car to drive. And I sort of showed this slide at the time, where you can imagine that the inputs to the car are on the bottom, and they're going through a software stack to produce the steering and acceleration. And I made the observation at the time that there was a ton of C++ code around in the autopilot, which was the software 1.0 code, and then there was some neural nets.
I gotta know, like, dude, I was following this graph. I just don't. What happened here? Someone has to, like, explain to me how to read this, because I read it like this is time, and it's just like it goes this way, and then all of a sudden we get here, and it's just like, yeah, now some of the code has been immediately replaced. And okay, more code has been replaced. Okay, actually, no, we reduced some of the code that was replaced. And then we get into an undifferentiable state where I don't know what happened here. I don't know what to do. I genuinely don't know how to read this graph. And I could just argue that I'm an idiot. Fair. That's the sinister hand of software 2. It's the sinister hand of software 2. Damn. It's not a graph. It's 2 code eats code 1. Okay, so somehow code 1 relinquished control from. Yeah, anyways, I don't know how to read this graph, but I understand the general concept, which is there was a bunch of C++ code. Now a lot of the C++ code is being removed or being effectively replaced with neural nets, which actually makes sense. Like this is a very sensible thing. What was that, big boy? No, I don't want any eggs. But thank you, though. This is a perfectly reasonable thing. I would hope that my car is not literally hard-coded switch statements. Can we all agree that that would actually be terrifying if this was just a bunch of switch statements that can't, like, change? I don't know. I'm just quite convinced that the devs couldn't figure out every situation. Instead, I want to take all those switch statements. I want to turn it into a matrix that has, like, 900 million switch statements, and then boom, call that it, right? It's broken programmer's hand, yeah. It's a bunch of, neural nets are just a bunch of if statements.
And they're doing image recognition.
Partial if statements.
I kind of observed that over time, as we made the autopilot better, basically the neural network grew in capability and size, and in addition to that, all the C++ code was being deleted and kind of like was, and a lot of the kind of capabilities and functionality.
All right, we got to go back to this graph just for one more second. I think that if I were to understand this graph, sorry, it's really bothering me. I know, okay, this is obviously autism moment. Just let me have it, okay? If I were to make this graph, I would have something that looks like this. If this is C++ code, okay? I know, here we go. We got to go back. This would be the software 2.0 code, right? And this would be time, okay? And this would be 100% of code, right? You know what I mean? And so you get this like nice, slowly filling in, taking over gap where you're just like, okay, I got this. I see what happens as like time goes on. We're taking up more and more of the slice with this code versus that code. But this, my brain just wants to understand it, okay? Because he keeps saying these words that make me think like this. But then it looks like that, and I'm so triggered right now, dude. I know this is ridiculous. Instead of looking at the graph, looking at his volume, it still bothers me. Okay.
Some neural nets in there doing image recognition. Basically, the neural network grew in capability and size, and in addition to that, all the C++ code was being deleted and kind of like was. And and a lot of the kind of capability.
Oh, like that, like this graph. That's what you're saying? You're saying like the neural net grew in size and capabilities, and then the C++ code was getting shrunk like that graph. Okay, I can't help it. I know I'm letting it go. I'm letting it go right now. I'm letting it go right now. Okay.
And functionality that was originally written in 1.0 was migrated to 2.0. Yeah. So as an example, a lot of the stitching up of information across images from the different cameras and across time was done by a neural network, and we were able to delete a lot of code. And so the software 2.0 stack quite literally ate through the software stack of the autopilot. So I thought this was really remarkable at the time. And I think we're seeing the same thing again, where basically we have a new kind of software, and it's eating through the stack. We have 3 completely different programming paradigms. And I think if you're entering the...
This makes more sense. Okay, I can understand this. This feels good. This feels good. Hey, again, would have chosen something like this, but we're just gonna, I'm just saying you could have also started having something right here. You know what I'm just saying? We could have just, you know what I mean?
Industry, it's a very good idea to be fluent in all of them, because they all have slight pros and cons, and you may want to program some functionality in 1.0 or 2.0 or 3.0. Are you going to train a neural net? Are you going to just prompt an LLM? Should this be a piece of code that's explicit, etc.? So we'll have to...
It's at least an interesting take. At least he's not like an LLM maxi that's just like, oh, all things should be solved with LLMs. I still think there's a lot of great things that you can solve, even with simple neural nets like radial basis functions. I still think that they could do a whole bunch for real-time gaming that people just aren't taking advantage of because they're so dang cheap. They're so cheap and so easy to understand, and they work over a fixed range, and it's beautiful, right? Like I actually really I think there's some cool stuff that you could do
to make these decisions and actually potentially fluidly transition between these paradigms. So,
or code, amazing. Well, I mean, what I mean by that is that there's some problems that code sucks, right? Code just sucks at certain problems. Hey, dog, is this a Waterloo bubble water? Like that's a crappy problem to solve. Okay, that's not a code problem. Okay, you just, oh, sorry, the light was slightly off. Turns out your code sucks and can't understand it because the light was just slightly different than it was before. Right? You know what I mean? That's what sucks so bad about like just code. That's what makes LLM so amazing, is that you just like, is this it? And it's like, yeah, that's probably it.
What I wanted to get into now is, first, I want to, in the first part, talk about LLMs and how to kind of like think of this new paradigm and the ecosystem and what that looks like. Like what is this new computer? What does it look like? And what does the ecosystem look like? I was struck by this quote from Andrew Ng actually many years ago now, I think. And I think Andrew is going to be speaking right after me. But he said at the time, AI is the new electricity. And
I think I understand what he's attempting to say here, is that electricity was a fundamental change to how society works, and he's claiming that AI is going to be that fundamental change, just like electricity was. Still, the statement just seems pretty ridiculous. I'm just throwing it out there. Like, those kind of statements are always just a little bit ridiculous to say. You know what I mean? They just feel a little bit ridiculous. They look a little bit, you know what I mean? It just feels weird.
I do think that it kind of captures something very interesting in that LLMs certainly feel like they have properties of utilities right now. So LLM labs like OpenAI, Gemini, Anthropic, et cetera, they spend CapEx to train the LLMs, and this is kind of equivalent to building out a grid. And then there's OpEx to serve that intelligence over APIs to all of us. And this is done through metered access, where we pay per million tokens or something like that. And we have a lot of demands that are very utility-like demands out of this API. We demand low latency.
I mean, I guess you can make anything kind of feel like it. I don't like this analogy. I don't look at LLMs like utilities. I'm not really, because that's just not how I'm going to look at this. I think you could try to fit it into this and say, hey, it's kind of like it, but I don't know. This seems like a bit of a stretch.
High uptime, consistent quality, etc. In electricity, you would have a transfer switch, so you can transfer your electricity source from like grid and solar or battery or generator. In LLMs, we have maybe open router and easily switch between the different types of LLMs that exist. Because the LLMs are software, they don't compete for physical space. So it's okay to have basically like 6 electricity providers, and you can switch between them, right? Because they don't compete in such a direct way.
Yeah.
And I think what's also a little fascinating, and we saw this in the last few days actually, a lot of the LLMs went down, and people were kind of like stuck and unable to work. And I think it's kind of fascinating to me that when the state-of-the-art LLMs go down, it's actually kind of like an intelligence brownout in a work.
Dude, that's a terrifying statement. That's a terrifying statement. An intelligence brownout. Do you really want? Bitch, you live like this? There's something about that. I think, there's something so true about this, though. Like, he really is pointing out something that's actually an incredible statement, which is that there's this entire critical thinking path that people have relied on for so long. And now, for the first time, instead of just offloading, say, memorizing phone numbers, memorizing emails, or even having my calendar automatically let me know, as opposed to me looking at my calendar, right? There's like an entire kind of world that we've already browned out, if you will, that if one of these services go down, you're just like, dude, I missed like 4 meetings. My calendar wasn't working, right? Like, I get this. Like, this does happen because we're so willing to offload stuff. But the idea of like critical thinking being the thing you're offloading, and then when it goes down, you're just like, I can't do anything. Like, to me, that's like it's a very separate thing. I'm not sure if I want to be in on the cognitive outsourcing. I get it for researching and doing stuff, but man, cognitive outsourcing, that seems a little disturbing. You know what I mean? Brownout, okay, for those that don't know what a brownout is, just in case you're wondering, whenever you have like an area, like let's just say you have an area like this, and there's like a section of the area that doesn't have power, they call this a brownout, right? It's not a blackout. A blackout is when there's like nothing. A brownout is when there's some amount of stuff out, but not everything out. Okay. Right? A whiteout is everything works. Yeah, I guess, if we're going to keep on going with this analogy, which I think, it's like the idea of lights on and off. So there you go.
It's kind of like when the voltage is unreliable in the grid, and the planet just gets dumber the more reliance we have on these models, which already...
Dude, that has to be kind of a scary statement. The planet gets dumber with the more reliance we have on these models. Huh. Okay. Why not a grayout? I agree, a grayout sounds much better than a brownout. If it's a blackout for everything's off, then a grayout would be like partially off. I'm actually much more on board for a grayout, because a brownout really is just kind of confusing. Maybe there's maybe there's a reason why that does exist. But either way, that's like a terrifying statement.
Is like really dramatic, and I think will continue to grow. But LLMs don't only have properties of utilities. I think it's also fair to say that they have some properties of fabs. And the reason for this is that the capex required for building LLMs is actually quite large. It's not just like building some power station or something like that, right? You're investing a huge amount of money, and I think the tech tree and for the technology is growing quite rapidly. So we're in a world where we have sort of deep tech trees, research and development, secrets that are centralizing inside the LLM labs. But I think the analogy muddies a little bit also because, as I mentioned, this is software. And software is a bit less defensible because it is so malleable. And so I think it's just an interesting kind of...
I mean, I think what I'm learning from this presentation, at least in this current moment, is that you can make complex topics, when you simplify them, look like a lot of other things. Right? You can metaphor something pretty easily, is what I'm kind of gathering at this point. That's at least how I'm reading this, is just like you just compared it to a utility, and now you're comparing it to a fabrication lab. And you're like, okay, if he says quantum, I'm out. I don't think he's gonna say quantum. Quantum and AI hasn't quite hit the super AI hype mainstream, but there's coming a day. I just want you guys to know that we are gonna have quantum AI, and it's gonna be the single-handed end of the hype cycle universe. Yeah, our brains love rational starting points. I just don't get this.
There's many
honestly, I
analogies
just don't. I
analogies you
don't
can
quite
make.
buy
Like
this.
a 4-nanometer process node maybe is something like a cluster with certain max flops. You can think about when you're using NVIDIA GPUs and you're only doing the software and you're not doing the hardware. That's kind of like the fabless model.
Right.
But if you're actually also building your own hardware and you're training on TPUs, if you're Google, that's kind of like the Intel model where you own your fab. So I think there's some analogies here that make sense. But actually, I think the analogy that makes the most sense, perhaps, is that in my mind, LLMs have very strong kind of analogies to operating systems. In that this is not just electricity or water. It's not something that comes out of the tap as a commodity. These are now increasingly complex software ecosystems.
Okay.
Right? So they're not just like simple commodities like electricity. And it's kind of interesting to me that the ecosystem is shaping in a very similar kind of way, where you have a few closed source providers like Windows or Mac OS, and then you have an open source alternative like Linux. And I think for LLMs as well, we have a kind of a few competing closed source providers, and then maybe the Llama ecosystem is currently like maybe a close approximation to something that may grow into something.
Again, I think, you just have a complex enough topic, you can just make analogies out of anything. Because, yeah, I mean, I guess you